class playlist. It had 4 properties: name, track count, description, is top 100, which was a Boolean. We had an initializer for it, right? The initializer took in a name, the track count, description, and is top 100. We had an instance method called info, and we went ahead and we created a playlist dictionary here, where we said the name is the key, track was a key, description is a key, right? And is top 100 is also a key. So far, so good. Let's talk about initializers a little bit. So here, that initializer is known as the designated initializer. So we'll update this name to say designated initializer. That initializer basically is the one initializer that has all the values for the properties. In our case, we have 4 properties. It covers all 4 properties. Yes, exactly. So this is the designated. Like you're the designated driver, you're the one taking charge of driving. This here is that designated initializer. You could have other initializers, right? But most likely you have one designated initializer, right? It initializes all 4 properties we have: name, track count, description, is top 100. Okay, perfect. So far, so good. Other initializers we have, or we'll talk about today, we'll talk about what's known as a failable initializer and a convenience initializer. We'll actually handle both in the same initializer, where a failable initializer returns you nil if it wasn't able to be created. So let's see what that looks like. Scroll up. Oh, we have that code. Oh, sorry, the notes. Yeah, sorry. So here we said designated initializer initializes all the properties of the class. Here we have 4, so all are initialized. Okay, awesome. Can I scroll down? Questions? Up, sorry, the notes? Okay.
So all of these properties are instance properties?
Yes. They're all instance properties, vars or lets. There's no static there. Cool? All right. So let's move on to what's known as a convenience initializer. Let me scroll down if people still typing. So convenience initializer and failable initializer. Right. Convenience initializers, as the word says, it's the next way to initialize some property or initialize some class, right? Where you're not using the designated initializer explicitly, but in our case, we'll be using a dictionary to create a playlist. Everybody with me? We have our dictionary at the bottom. If you scroll down, we have a dictionary there. It's called Playlist Dictionary. We all saw that, right? So far, so good? So we'll create an initializer specific, a convenience, right? To create a playlist using a dictionary. We'll use a convenience initializer for that. And our convenience initializer will return either we have a valid object, in that case a playlist, or we have nil, right? If you're doing that with an initializer, that initializer is known as a failable initializer. If it returns some optional, we'll see what the syntax looks like. So here we'll have one initializer taking care of both instances of our terminologies there. Convenience in the fact that it does a different creation for us. We're using a dictionary as opposed to name, track count, dictionary description. And it's failable because it could fail, right? What if our dictionary has a bad value? In that case, we don't create a playlist. It returns nil. We'll see what that looks like. So here, convenience initializer starts with the keyword convenience here. It's an initializer. So in structs, you do not use the keyword convenience. In structs, you just use init, whatever you're doing. But in a class, you need to mark it convenience. So here we have a convenience initializer. We said it's failable, so we return an optional. So we have a question mark right after init. It's failable. It could fail. What does our initializer takes? It takes a dictionary, right? It takes a dictionary here, where the key is a string and the value is any, right? This is very similar to our dictionary if we scroll down. If we scroll down, we have our playlist dictionary in the code we select, right? We type annotated it, and we said the key is a string, and the value is type any. Is that correct? Right? So that's the same type we expect here in our parameter. We have convenience initializer. We'll be creating an object with a dictionary. Everybody with me? We could create a playlist with name, track count, right? Or we could also create a dictionary. We could also create a playlist using a dictionary. Everybody with me? So far, there's two ways we could create a playlist. Everybody with me? The first way is the designated initializer we have, if we scroll up. And the second way is using our convenience initializer using a dictionary. Everybody with me? Right? We'll come across that use case a lot in Swift as we go through our career, using some dictionary to populate, to create an object, right? Dictionaries are used throughout the language. Yes? An instance of playlist. We'll be creating an instance of playlist using the dictionary at the bottom. We have to go ahead. Yes, exactly. Very good. Are we good with typing? Can I scroll down or up? So the dictionary we'll be using is this playlist dictionary here, right? The key is a string. So far, so good. The value is type any, right? Because as we said on Friday, the value could be an integer. It could be a Boolean. So any type. I can't say it's only a Boolean. That would fail. Everybody with me? So when we create a playlist, this is not a playlist. We agree? This is not a playlist, right? This is a dictionary. So far, so good. But we'll take that dictionary to create a playlist. We could have an array of dictionaries, right? Maybe we make an exercise tomorrow. Or we have it in the classes lab. There's an array of stuff you have to create. Go through that array to create objects as we go along the way. But at the end of the day, the way you create that object is using a dictionary, right? In our case here, we have a dictionary. We pass it to our initializer, and it gives us a playlist. Everybody with me? Okay, cool. So that's why we use our convenience initializer, because our designated initializer would not be able to do this by itself. Everybody with me? All right, awesome. So let's go back to our convenience initializer. It takes in a dictionary. The objective of this particular lesson is just to show us how to use a convenience initializer. That's failable, right? We haven't explicitly used guard. We've used it, but lightly. But here we'll use guard explicitly. Great. So I'll say guard. I'll start out with guard. And we said the guard keyword. What does the guard keyword do? What does the guard keyword do? Yes. Yeah, it's like if let, right? Like optional unwrapping, optional binding. It's like if let optional binding, but If we do get the value, we have access to the value throughout that initializer. Everybody with me? As opposed to having access only in the if let. Right? So here we use guard. We say let. What's the first thing we expect? The name. So here we use name, the name variable. We use our dictionary. What is the key for name? What is the key for name? Look at your dictionary. What is the key for name? Name. Okay. Yes, it's a string, but it's name. Thank you. So the key is name. If we go down, look, the key is name. So far, so good? When I ask you for the key for track count, it's track count. Next key is description. And the last key is top 100. So far, so good. When I ask you for the type, you tell me it's a Boolean. You tell me it's a string. For track count, the type is an int. And for name, the type is string. Very good. So let's use that knowledge there. So we're using guard to unwrap. So God unwraps. God says, again, we said a dictionary, a key, could not have a value. There's a possibility the value doesn't exist. Everybody with me? So it returns us an optional. It returns us an optional. We have to unwrap that optional. We could use if let, optional binding. We could use nil coalescing. We could use guard. Guard is awesome, especially in functions. This is a function. It's a method. So here we use guard, let, name, right? We use the dictionary key. So far, so good. And here we use typecasting. We saw typecasting on Friday. Here we use optional typecasting or optional downcasting. What type are we expecting? A string. Thank you. We're expecting a string. Why are we expecting a string? If you look at our dictionary here, this is a string. It's in quotes. That's a string. Everybody with me? And we agree that the value is a string, value is an int, value is a string, value is a Boolean. So far, so good. So we typecast it to the expected value. Let's put some notes here. So first of all, we're using guard, let to unwrap value from key in dictionary. And using also, we are using optional downcasting, the as question mark, to cast to expected type. Right? We did that on Friday. But Friday we ended up using nil coalescing, right? Okay, so here we have the guard let name. Name could be any name. Everybody with me? Right? From day one, we said name could be any variable name. Agree? Agree? So name could be any variable name. We call it name, it makes sense. And now we have a comma. We have a comma because we'll be unwrapping all the values. Everybody with me? Remember if let, we had commas, right? For optional binding, we could say, hey, if let optional bind my first variable, comma, my second variable, comma, my third variable. Everybody remember that? So here we could do the same thing. Use commas to unwrap all the values we want. With guard, everything has to have a valid value. If it doesn't, then we return nil. Everybody with me? All the values, very similar to if let. All the values needs to be true in order for the whole statement to be true. Do we agree? It's like having and. Not or, but and. This needs to be true, and this needs to be true, and this needs to be true. This is the same as saying comma, this, comma, comma, comma. Everything needs to be true in order for the whole guard to work. Everybody with me? Okay, so let's keep going and we'll see how we're doing. So next, what do we want to unwrap next? What's the next value? Track count, so we'll call it track count. Thank you, sir. And here we don't use guard. We use guard once. Everybody with me? Same as if let. So here, track count equal to dictionary here. What is my key? right? You see, part of it is consistency. You name your variable the same as your key, the likelihood of you making a mistake is less. If I call track count something else, like variable 2, right, that throws me off a little bit. But keeping them the same consistency is good here. So here I have my track count. What typecast am I doing here? Int, right? Oscar, we agree? Int? Eric? So here we have an int. What's my next variable or constant will be called here? Description. And dict here. And description. Be careful, anything you misspell, it will fail if it's not spelled correctly. Because anyone that fails, the entire thing fails. What is my fourth constant? Is stop 100, thank you, sir. Here, I have my dict here, and this is the stop 100 as what type? Bool, very good. At this point, I've unwrapped all my 4 values. So at the end of my bool, I type in else, right? I type in else, followed by open curly, close curly. Inside of the close curly, I say return nil. Return nil means it's failed. I wasn't able to create this object. I'm returning nil for my initializer. Remember, Objective-C made it easier to understand, like this actually returns something, but every initializer returns a value. All right, let's talk about that. Every initializer returns the thing it initialized or it created. Everybody with me? Right? You might not see explicitly return there, but every initializer returns the object it's created. I create a fellow called Julia, right? When I say fellow open parens, it returns me an object. Everybody with me? That's how I'm able to capture it in Julia. That's why I'm able to say Julia.h. Everybody with me? So this returns. Here, that's the first time we actually see the return keyword in an initializer because it returns nil. Right? I wasn't able to create it. I returned nil. And nil is valid because my init is optional. A lot of moving parts there. That's why we only do it in this case. Right? The initializer itself is an optional. It's an optional. It returns an optional. We mark it optional. The terminology for it is a failable initializer here. Right? It's failable. It could fail. Yes, it can. If one of those are a nil, the whole thing fails. For example, if I don't have a name, it fails. If I don't have a track count, it fails. It just takes one of those to fail, and the entire thing fails. Very good? Okay? There's instances for that. If you're creating an Instagram post, for example, I'm creating an Instagram post, and Instagram requires me to have a photo. There's no way I could create an Instagram post without a photo. You try to upload it to Instagram without a photo, there's some initializer like that says, hey, fail. Send back an error. There's no way I'm creating an Instagram post without a photo. Part of it is the photo. It is the photo, right? Without the photo, I don't want to see text. This is not Twitter. I want a photo. So I make my initializer failable. Everybody with me? If I do not get a photo, return nil. Tell the user missing photo. Right? But with the interface of Instagram, it's impossible to go to the next screen without having a photo. Everybody with me? Description doesn't really matter. Like the picture is 1,000 words, right? Who cares about the caption, right? Everybody with me? Yes, sir.
So is this failable like set of only possible means? Is this
No, it could be separate by itself. The two of them could be separate initializers altogether.
So I'm a little confused as to what it means initializer.
Well, convenience in that case, we do not use the designated initializer with it. At our convenience, we make it to only use a dictionary. Just for dictionaries, because we'll be passing it a dictionary when we want to create our playlist. So it's a convenience to that. We still have to call our designated at the end. We'll see that. We'll see that. Cool? At the end, we still have to call our designated initializer. Yes? There was a question.
It's like when you fill out some form online, right? And you don't, like, you forget to put in one line.
Yeah, something like that. So as Luba was saying, picture yourself doing the pursuit application and you're required to put your salary. You figure, hey, I'm just going to not put my salary. You're not going to be able to continue without putting your salary. So it's going to force you to put that in. It's a requirement. Yeah, so a bit similar there. Cool? All right, so we good with our guard. Can somebody walk me through the guard? I know we typed it out, but can we explain what's happening? Chelsea, explain to us line 25 to 29. If they all exist, right? If they all exist, right? Exactly, very good. So the last point there that Chelsea captured, if they don't exist, return nil, else, right? We see the else here, right? That's our if else. So guard is like if else, right? So guard is the if let there. And if it fails, return nil. Yes? We don't need a bracket. Oh, we don't need a, no bracket for that. Only for the else. Yeah. The God, yeah, exactly. The God is there. He's standing in front of the wall there. He's like, everybody needs to pass before I let you in. Right? So that's like guard. If one, yeah, the whole thing is yes. If you don't have all your correct credentials, your ID, your SS, all that stuff, you can't get inside the DMV there. Does that make sense? Very good. What's that? You're wishing you had before that, right? Before you went to DMV? DMV, we all love it. No, we don't. How we doing? We good? All right, so here we have an error, self-used before, because we haven't initialized our properties. Remember, an initializer, the goal of an initializer is to initialize all our properties. We haven't done that. We have not done that. So let's go ahead and do that. So here, on line 31, we'll say self.init. Here we are calling the designated initializer. Everybody with me? Everything has to go through the designated initializer. We have a designated initializer. Do we agree? Do we agree? We have a designated initializer here, up top here, designated initializer. It expects a name, track count, description, is top 100. The convenience, the person calling it, it's their convenience. They only pass a dictionary and they're done. Everybody with me, right? I pass in a dictionary, I am done. But we, the one writing our initializer, we need to complete it. It needs to call our designated initializer. Everybody with me? So here, my first argument is expecting a name. You could put a comma and press enter to make it more readable. A track count, we pass in track count. It expects a description, we pass in description. And lastly, it expects, is top 100. We pass in is top 100, like that. Let me take that down a little bit here. All right. So at this point, we have completed our convenience initializer, right? It takes in a dictionary, that's all. It doesn't take in anything else, just a dictionary. When we're ready to use it, or the person using our function, our initializer, they only pass in a dictionary, that's it. And what they get back is a playlist, or nil, right? They get back an optional. Questions? Eric, you have a question? Yes, in that case, the first thing happens, the dictionary, it takes a dictionary, but the user doesn't see anything else. All what the user sees is, hey, the thing expects a dictionary, and I get back an optional. When we call it, we'll see how it's being called. If it returns nil, it doesn't continue, right? Good question, good observation. So here, if I go through my guard and I return nil, return exits the function. Remember the break keyword? Remember the break keyword. Break exits the loop, right? You see break, that's it. It's done. It exits the loop. In our case, we say return nil. It does not continue, as Mr. Eric is pointing out. It doesn't continue to line 31. Return means just get out of the function. Everybody with me? So the return nil here says exit. Something went wrong, I'm done. Just return nil. And nil, obviously, is nil in our optional. Very good. Everybody sees that. So I do not get to 31 if any of my values are nil. Do we agree? And return is very similar to break. So return exits the function here. So return exits the initializer. Does not continue through function. Okay? So far so good? So we know what guard does. Guard unwraps an optional. We stack them up because if any fails, everything fails. If everything passes, then we come down to line 34. If all values are available in the guard statement, then we call our designated initializer. Cool. Because we have to set all the properties. Remember, when we get to line 35, we haven't set the properties yet. When we get to line 35, when we get here, we haven't set the properties yet. The only thing we've done is find out if the values exist. Yeah, in the guard, the only thing we've done is find out if the values existed. But we haven't set the properties. We haven't set our properties here. Our properties, Luba, we haven't set our properties. So we have to call our designated initializer. Yes, sir?
So the main goal of the guard statement is to make sure the properties are
Yes,
if we're not returning.
exactly. Yes, that's it. So as Eric is saying, the main goal of our guard here is to make sure that everything has a valid value. Does my name have a value? Yes. Does my track count have a value? Yes. My description, does it have a value? Yes. Is top 100, does it have a value? Yes. If all has a value, go ahead and initialize the entire object. Everybody with me? All right, so let's test it out and then we'll make it fail and see what happens. So now let's go down. We have all the code, correct? We have all the code? Which part? The 35 part? The last part. So make sure you're saying self, name, track count. What's the error? Okay, so make sure the label names are correct. We have 4 parameters. We have name, track count, description, and is top 100. Your designated initializer, make sure it's the same as we have here. Well, we had that earlier. Cool? All right. Okay, so let's go down to our dictionary here. Everybody go down to the very last line after our dictionary. Let's go ahead and attempt to create a playlist, right? Actually, let me task you guys with that first, and then I'll come back and do it. Because we should be able to start off somewhere here. So create a playlist using, that's also part of the lab. So I did not hear it as one of the questions we have. So I'm assuming we all got it correct. And it was even harder. We had to go through an array of dictionaries. So create a playlist using the playlist dict above and print the track count. Yes. Okay, that's a start. No, do it. Go ahead. Do it. Okay. Okay. You said like optional or something? Okay. So maybe like that way is the best way, like using some convenience initializer. Yeah, yeah. Or using nil coalescing, which did the question come up? Did the question come up? Did you bring the question? Was there a question? Did you did you bring the question forward to us? Okay. I'll come and see what your screen has. Yeah. So either you use nil coalescing, which will give you the thing, like a default value, when you create your object, or you could use a convenience initializer. Other than that, I'll take a look at it. Cool? Please pull me later. Take a look at it. All right, so here we are creating a playlist using the playlist dictionary above and print the track count, right? So output should be output, what's the output here? 128, right? Let me give some more. Create a playlist instance. And here we have two initializers. Which one would we use? Would we use the designated or the convenience? Right? How many we have? How many initializers we have? Two, right? Which one would you use? Line 11 or line 22? Line 22. Thank you. Why? Oh, why? Because we have a dictionary. Our designated doesn't take a dictionary. No. I'm waiting for more responses. Like, does that make sense? Yeah. Because we created it from a dictionary, and we do not have a dictionary on our designated, correct? That's why we created the convenience, for the convenience of it, right? Using a dictionary. Yulia, how you doing? Started? Cannot import? Playlist.key. Well, the playlist.key, there's no playlist.key. That key is not a property. Line 35. That's the entire initializer. I'll get it on screen. I'll try. I can't. Almost. So that's the good. Okay. Yulia, when you have a question, shout out. Don't stay stuck. Yes, sir.
For description, it's not in the on line 35.
It's not spelled correctly.
It says cannot convert value of type any to expected argument type string.
Okay, so make sure you have for descriptions as string here. As string. That's why we typecasted it. Cool. Mr. Dan, how you doing? How did you start? How do you start creating an instance? Does it mean what? Oh, I want you to print the track count. And print the track count of the playlist. Yeah, I think that's the number, right? Yeah. That's all. That means you successfully created a playlist, sir. Very good. Shania, how you doing? Wow, I saw fire from your eye. Right into me, right into my body. Mrs. Sering, you close? Are you close? Are, optional. What do we do when we say optional? You could nil coalesce it. You could use optional binding in that case. Because if you nil coalesce it, what's the default value? It expects a playlist. We all should at least be able to say let name equal to something, right? At least that point, right? Cassandra says yes. Cassandra, you done? Almost there? Confused. So create a playlist instance. Do we understand that part? All right. Using the playlist dictionary above, we created a convenience initializer just for that. It takes in the dictionary. It returns us an optional playlist. Yes. So okay, all that is good. So what part? How you do it? How you do the thing? First of all, how do we unwrap an optional? What are the options we have? We have nil coalescing, we have optional binding, right? So we could use one of those. So let's get back to it, right? So here it says create a playlist instance. Everybody with me? At this point, we should understand create a playlist instance what it means. Stop me if we don't, please. Do we all understand what that means? Create an instance, yes? So here we start with like the let keyword. I say playlist. I'm creating an instance of what? Of playlist. Very good. So here I have playlist here. And look, I open my parents, and look at that. We have two initializers. The first one is what? What's the first initializer we see there? It's a convenience initializer. Let's use the terms. Right? The first one we see is a convenience initializer. That's the one we created. It takes in what? It takes in a dictionary. Thank you, sir. Right? That looks like the one we need because our question says create a playlist instance using the playlist dictionary above. Does the second one take in a dictionary? No, there's no way we could create a playlist with this. So for our convenience, no pun, for our convenience, we created this convenience initializer that takes in a dictionary. Everybody with me? Yes, sir.
Do we fill it out like we did the top words? Name, then
We don't have anything to do but just pass in a dictionary. Again, it's convenience. We don't have to do any extra work. The person using this initializer doesn't have to do any extra work but just pass in the dictionary. Yes. Well, we need to go deeper in there. How do we get to 128? We know we're looking for track count, right? So when we get the playlist, we say print playlist.track count. In our case, we have the dictionary value already. It's 128. If you look at the track count for dictionary, up top, it's 128, the value. So we after that value. So the output should be 128, if it was correctly done. Does that make sense? What is your number? What's your number? What's your number? It's not 128? No. So let's see, and print the track count of the playlist. So we know how to access the track count. We say playlist.track count. Does that make sense? Yeah, but stop me if you. Is that good, Mel? Mel, is that good? Yes. What? No, that's not at all. That's far. Remember, we started saying that's a dictionary. That's not an instance of playlist at all. Yes, with the type. Very good. Okay, so here we agree that we're using our convenience initializer. Yes, sir.
So why can't we set like regular initializer to the dictionary? Is that something that
if you get data from, say, the internet or whatever, or you get some data from like a dictionary, right? There's no way to get access to the name. You could do it yourself, right? But here we have a convenience initializer that takes in a dictionary, so we don't have to explicitly unwrap our dictionary ourselves.
So instead of putting each like individual thing in the dictionary, just taking it collectively.
Exactly, exactly. We've done the work for that already in the initializer. Does that make sense? So if you catch yourself doing code where you think it should be an initializer, that's where you like stop yourself. I should maybe create a convenience initializer for that. Does that make sense? All right, very good. Now here we say we agreed we're gonna use our convenience initializer. What do we pass in? Dictionary. What's it called? Playlist. So we type in playlist dict here. What does this return? What type is playlist right now? Option click on playlist. What type is it? Array. Wait. Array. What code you working on, sir? Cool. What type is this? An optional playlist, right? We have playlist question mark, right? So here we can't use an optional directly, we agree. So far so good? So how can we use that optional? How can we unwrap it? We could nil coalesce it, but we have to give it a default playlist. Just keep that in mind. If you are unwrapping it, you have to give it a default playlist. You with me? Right? So you have to say nil coalesce this. Whatever coming after the question mark has to be a playlist. Do we agree? Okay, so in that instance, using optional binding works better here. So I'll say if let, like that. At this point, what type is playlist? Is it still optional? Is playlist still optional? Option, click on it, please. Is it still optional? Yes or no? No. Okay, perfect. So we could use it now and say print. Actually, you guys go ahead. Print the track list. Right now we have the playlist already. Now print the track count. The track count is whatever. So using the print statement, go ahead and use string interpolation to say the track count of the playlist is 120. So we're saying the track count of the playlist is 120. But we're not hard coding 128, right? We gotta get 128 from somewhere. Yeah. Yes, sir. I see one. Here we're saying track count. The track count of the playlist is in your print statement. If we want to get a track count, what do we use? Are we using the dictionary or the playlist we just created? What do we use? If we want to get access to track count, what do we use? The playlist we created or the dictionary? The playlist that we created, right? The dictionary doesn't have any properties on it called track count. The playlist does. Let's be clear. Very good. If you don't understand my prompts, let me know. So here. event exists. Yeah, that was it. You didn't find it. No, you didn't find it. You checked out the mirror trying to find it. Oh, because this is optional. Put the number back. This is optional. If you do not so if you do not do this, you can take out the roll over there, and we'll go ahead and yeah, it's gonna be optional. No. Yeah. No. It's gonna be optional. Now you have to do some more. Just take out track time and just but the whole thing with option there. Okay, Mr. Eric, come complete this for us, please. Completing the last part, the print statement. So Eric is printing out the track count for us using the playlist instance, right? He's using string interpolation. He's going to run the playgrounds. And we get 128. Thank you, sir. So here, we were able to use our convenience initializer. Questions were asked, why do we need to unwrap our playlist? We need to unwrap our playlist in order to work with an actual playlist, not a playlist optional. We don't want to work with a playlist optional. We want to work with a playlist. So we unwrap it. Yes, sir. Optional binding. So here, Mr. Eric was using optional binding. Right? To unwrap. Yes, sir.
What's the difference between initialization and
Okay. The convenience is exactly for that. I have a dictionary. That's what I got back in my data. Like, we'll do an example where we do the project. We have a dictionary, and the only way to create objects from it is to create some sort of convenience initializer. It will be seen as more usable code, better code, right? First of all, you have an initializer now. You could take that object anywhere. Okay. If you have your function anywhere, like outside of your, you might have your function outside of that object. At that point, you've decoupled it. You see what I'm saying? You have your function one place, and then you have your object itself a different place. Your object should be able to encapsulate all this functionality. Okay. If that makes sense. Yeah. So when you start writing a function to do that, stop yourself and be like, hey, that should be an initializer. Cool? Yes, sir. So if we didn't use optional binding here, it would be playlist question mark dot track count, which would be an optional. It would print out as optional 128. Right? So here, if we take out, let me just create a new one. So let other playlist equal to playlist. Other playlist here, use our same dictionary, playlist dictionary, and let's go ahead and print it out. So print track count is playlist, other playlist dot track count. Right? At this point, it's an optional. Right, Greg? At this point, it's an optional, so if we were to print it out, right? If we were to print it out, it would be optional 128. You see what I'm saying? Yes, you could use nil coalescing on there, but you don't have an object yet. You still have to do that for every instance. Definitely. What if I tell you to print description for me? Then you have to do nil coalescing on this. Right? If you have an app, you're not going to show the user optional 128. Right? Please. Right? Yeah, so the user is like, what's this optional 128 thing?
Alex, I just the info instance method on the previous optional and I converted it to a regular name. So it's like
You used.
so you kick out the print statement and just put like other playlist optional dot info.
This, you did that?
Yeah.
Best pop songs, 28 is, what's the info do again? It just prints out the info here. Info is on the name. And what's the int?
Contains 128 tracks.
Why is mine 100? Where's that from? 1 second. 100 Spotify. Oh, and you put the name up here in the info?
Well, track count is in there as well.
Oh, okay. Oh, sorry. Yeah. So in that case, it saw the internal name in that case here, and it just printed out 128, as opposed to doing it outside of the struct, outside of the class. That's the difference, right? In our info here, right, that name here is not an optional. If you see name here, it's not an optional. So it printed the name as the name is, as opposed to calling it in our print statement. Mr. One, right?
But if that the name from
The name exists already because you said the name.
this is where
It existed when we used our convenience initializer here. Convenience initializer here. We set the name here,
okay, so it is grabbing it from
the dictionary.
okay.
Remember, you have to call this designated initializer. No matter what, even if by the way, your convenience initializer could not take any parameters, like it could be empty, but I still have to call my designated initializer in it. Let me show you what I'm talking about. So let's create one more convenience initializer, and well, so here I'll create a convenience initializer. You can create as many of those as you want. Init. And let's say we'll just do whatever, name. Just take a name. Or don't take any name. And here we will do self.init. You always have to call self here, dot initializer. And here we'll say name equal to pursuit coding list, whatever. What else we have? Track count. Track count, whatever, 200. Track count 200 and description. And lastly, we have is top 100. I'll just say false here. Right? Our initializer doesn't take in any parameters. Do we see that? Do we see that? Right? So now I could create a playlist without any parameters. Let's use it. Everybody type that out already? Okay. No parameters. But our default or our designated initializer has some default parameters. Everybody with me? So if I just want to create some quick playlist on the fly, like think about it like Spotify, just get me a playlist. It just goes ahead and just creates a random playlist. Maybe here you could have some array doing some random thing. Like get me some a random name. Right? let's actually do that. Let's just create whatever, names. So names, and then we have some random names here. I will take in this. Anybody have some playlist names? No? Nobody? Just give me some names. Some playlist names or I don't know. What? Study playlist? That guy is so studious. Alright. Anybody else? Mr. One. Give me one else. Give me something else.
Neighbors at 2 a.m.
That's it? Which one was it? What?
My neighbors at 2 a.m.
Well, that's not even that's not safe space, man. Any other playlist? Wow. All right. Whatever. So we have some. Which one was that? Sorry. No. Sorry. I didn't get that. Was it?
Oh, it's at
Morning Run. Okay. 90s. I heard that. What's the other one you said? What? We're gonna create a random name. Okay. So Morning Run. But we haven't even written it out. Right now we just have the basic template. Let's use it and then questions are gonna come. So now we have names, and then for our name here, we'll say names.random element, new coalescing, right? At this point, what do we have? We have an array of names. Every time we create a new playlist using our convenience initializer, it doesn't take in any arguments, our default initializer, our convenience initializer here. And we go ahead, we grab a random name from our names, and that becomes the name of the playlist. So far, so good? So basically, this creates a random playlist. The description will be the same, the track count will be the same, but yes, we could make all those random. Everybody with me? All right. Are we ready? Can we go down? Okay, so we'll scroll down, and we have playlist here. Let's just create random playlist using the convenience initializer we have. So here we just say playlist like this, and print random playlist.name. Right? So here, this is our initializer. A mini. This is our initializer. It doesn't take in any arguments. So far, so good? Because that's what we said. We said we have a convenience initializer. It doesn't take in any arguments. It creates a playlist here by calling the designated initializer and using any of the names in our array. Yes. We could keep going on. We could make everything randomized. Go down, like here. Oh, where we created the thing? Okay. So far, so good? So this is the convenience of a convenience initializer. Does that make sense? So now I could just create the next random playlist here on the fly. So random playlist. Whatever, two. Some playlist. And print it out. This is random playlist 2. If we run the code. Right, the first playlist, we got Zumba Rocks. The second one, we got 90s. Everybody with me? Everybody with me? Right? If we run it again, there should be different values. Right, I got Mr. One's study playlist, and I still got my 90s. Everybody with me? Very good. Oh, warning. Yeah, we still have the warning because this guy is optional. 1 second. Everybody done with the bottom here? All right. Warning. What line? Where we created this guy?
Yeah.
You never use names, probably. Did you use names? We use names in here.
Oh,
We use names to create like a random name. Cool? Very good. Scroll down. All the way down here. Okay. We'll do one more failable. We'll do one more failable initializer, and then we'll wrap it up. Yeah.
So if you would have given, convene the second convenience and the order, element, but you would have said that they have to take in.
We could just pass a name if we want, where we only require a name, and then everything else is a default.
But the name would be a string, so that means that it will be used as application.
Yeah. Whatever name we pass in. Yeah. Yes.
so the convenience initializer, failable initializer, same.
No, they're not the same thing, right? Because we broke it apart, right? We broke it apart by this example here. We broke it apart here. That has no failable. There's no failable there. Failable becomes when you make that guy optional. Ugh. When you make this optional, like it could fail, right? But convenience is the amount of parameters you give it. If that makes sense. You might want to have something without parameters and just give it default parameters. You might have something with just one parameter, just name. Cool? All right, so let's do one more example. Everybody finished typing? Yes? Okay, let's do one more example and then we'll wrap it up. Let's create, what are we creating? Some initializer here that takes in a name string. Okay, I will make that guy failable, sorry. And we will say self.init here. Name is the name that came in. Track count, we'll just pass in 34. Description, we'll pass in currently trending and is top 100. We're passing true. What else we got going on there? That's it. Okay. One other thing. Let's see. So here we'll say if name dot count. If name dot count is less than 5, then return nil. Right? So in that case, somebody's creating a playlist. If the name dot count is less than 5, we cannot create it. Or maybe less than 3. That's aggressive. Right? If the count is less than 3, we can create that particular initializer. Yes?
Does that mean that even if it's a random element, it won't choose?
This one doesn't have anything to do with random.
So when it says that, when you say that the name count,
The name pass it in. Like I'm creating a playlist, I want the character count to be more than 3. Right? The character count.
but you're all putting this all in the same.
Like the name could be whatever, the name, it cannot be less than 3. So I cannot have a playlist like TH. Not a valid playlist name. Right? That's just me, the way I wrote it. It has to be the count. If count is less than 3, return nil.
So these are all the things you're putting inside of a class. You don't necessarily have to do that.
Yes, exactly. You see, like when we create a string, string has so many initializers. Let's take a look at string real quickly. Or int, for example. Let's take a look at int. So int Swift.
Alex, real quick.
Uh,
The initializer, and multiple initializers have taken the same arguments.
not the same exact arguments, because that's an error. Yes.
The parameter could be you're looking for one specific thing, but you still have to name all of the different variables that are in.
Yes, you still have to initialize everything. Very good. So let's take a look at int, for example. Now, int from the Swift language, right? Here we have a failable initializer, right? Init with some number. That could fail, right? Our init with string. Remember init with string? When we say int and we put parents, a string in there. So we have, let me go back and show you guys real quickly. So let's go all the way to the bottom. If I say response, we've done that from like week 1. Int some response, 80. Right? That's an initializer. Everybody with me? Int here. We casting it. We're like, hey, I want you to be an integer. Everybody with me? Tiffany? I have. So here we have int. This could be nil. If we option click on response, what do we get back? Optional int. So that here is a failable initializer. It could fail. There's no guarantee that 80 is an integer. Right? So here we have, for example, init here has an optional. It could fail. Very similar here. This could fail. We agree? Is 80 a number? No. So this is optional. Response here is optional. It's an optional integer. So this is very similar to what we just created here. Our initializer, our failable initializer, name. It could fail. Let's try to actually create one. Let's create one down here. I'm at the very bottom. So create playlist with name, for example. And here I'll say playlist. I'll say playlist. And now we have more initializers than one, right? We have our convenience that doesn't take in any parameters or arguments. We have our convenience that takes in a dictionary. Everybody with me? Everybody with me? So right now we have 4 initializers. One that doesn't take in any arguments. One that takes in our dictionary as an argument. One that takes in our string as an argument. Right? One that takes in a string as an argument, everybody? And one that takes in all the arguments, which is the designated initializer. Everybody? Right? So if we go ahead and we use the one, you see 2 of them are optional, right? Which makes sense. We have the name optional, where it needs to be, the count needs to be greater than 3, or greater than 2, for example. Right? The count of characters needs to be greater than 2 in order for it to pass. We have the dictionary. It's optional as well, because maybe one of the keys are missing. So far, so good? So let's test out the name. And for name, we pass in RE, like that. And we know it's optional. So far, so good? If I option click on this, it's optional, correct? Okay, let's go up. We'll come back down. What did we create? We created this guy. Everybody has this code?
Okay, so how come this was specifically where,
The initializer is based on your use case. In our use case, we're saying the user cannot create a name if it's not greater than 2 characters, the name of that playlist. So we're saying if name count is less than 3, do not create that playlist. But if it is greater than 3, go ahead and create it with the name that you passed in.
also that's part of the name, but then you still have to put it on the server.
Yes, we put in default values for now. Yes, sir.
What is some of the closure expression?
Closure expression is unused. So you have, let me just slack it out because we're very close to getting to the end here.
I don't know why I had name.count is. That's why.
Did you get it?
Yeah, because I had this.
Okay. I'll slack it out either way. So at this point, I slacked out the code. Let's all get on board. So we have, the last initializer we have is the convenience init that takes in just name. So far, so good? It takes in this name, and the name needs to be a certain length, or else it fails. It needs to be greater than 2. But you see, you could create initializers for each case that you expect your user to use your class or your struct, right? If you expect the user to maybe just like some random playlist they don't care about, you could have a random playlist. Just get created from something. If you're expecting your user to have a dictionary passed into your initializer, great. Supply them with that. Initializers on int, we saw the same thing. We could say, create me an int from a string. If that wasn't possible, that would give us headaches in Swift. So as you develop in your programs, think about what initializers that you need for your object, right? Question? Yes? Name not count. Oh, the character length. So we know name not count, right? Was that, you have what? Yeah, but the name is a string, correct? If I say name that count in our example here, string that count, what's the answer? Yes, exactly. No, that's fine. A lot of moving parts. So here, what's the count? 2. So will that pass? No. So it returns nil. Everybody with me? All right, so let's test it out. Are we all done here typing? Okay, so let's go down and create. Okay, so let's take this out for now. So we have our playlist here. Name is an optional. We know that. So we say let's unwrap it. And here we'll have an else to say print playlist not created. And here we will have a print statement saying playlist with name was created. All right. So here we have an else because we know so far what we have in there is going to fail. So we capture it in the else statement. So if we're able to unwrap or create this playlist, it returns an optional. If we're able to create it, go ahead and print out playlist with name was created. If it failed, the only reason why it fails is if the count is not greater than 2. Everybody sees that, right? It will come in here and say playlist not created. So let's run it. Right? Indeed, the playlist wasn't created. Why? Because RE is not equal to 3. Everybody with me? Or greater than 3, right? It's not greater than 2. But if we were to complete the playlist name, right? If we update the playlist name now, what happens? What happens? Does it get created? Does it not get created? It gets created, right? Because now we have a valid name. The name is greater than 3 or greater than 2 here. So we run our playgrounds. And now we have playlist with reggaeton 100 was created. Everybody? Okay, let's go through it again one more time. The whole lecture was just about initializers. How we use them, why we use them, how we use them, right? Here we created 4 initializers. Let's go through the code again. Our class is called playlist. It has 4 properties. So far, so good. We agree that the properties are not initialized. Everybody agree? Stop me if you lost, please. This is like assessment week. We created a class playlist. It has 4 properties. They're not initialized. So we need to create an initializer because we're in a class. So far, so good. We're in a class. We need an initializer. We started off by creating this designated initializer. Our designated initializer initializes all the properties that we have. How many properties do we have? 4. Very good. So here is defined as a designated initializer. That's the terminology for it. Initializes all the properties of the class. Great. Next up, We came to a situation where we had a dictionary. We had a dictionary object at the bottom. It was called playlist dictionary. Everybody with me? Right? How can we create a playlist from a dictionary? We created a convenience initializer that takes a dictionary. So our convenience initializer here takes in a dictionary where the key is a string and the value is of type any. We came into our initializer, we unwrapped every key to make sure it has a value. If it doesn't have a value, it fails. If it has 3 out of 4, it fails. 2 out of 4, it fails. Anything that's not 4 out of 4, it fails. When it fails, it returns nil. Right? It returns nil. That's why it's marked optional here. This is called a failable initializer. Right? So here we're using a convenience initializer and a failable initializer. It could fail. It's optional. Maybe calling it optional initializer would probably be better, right? But it's called failable initializer. Right? You mark it with an optional here. So we're able to use guard. We saw what guard did, right? Here we use guard let to unwrap all the values. Any values that don't exist, the whole thing fails. If all the values do pass, we have access to all the values on line 35. The values is name, track count, description, is top 100. We have access to all 4 values. So now we could go ahead and call our designated initializer here. This is calling our designated initializer, which we have above. Our designated initializer takes all the parameters. We have to call it. Right? The user of our initializer doesn't see that. That's not their business. All what they care about is just passing in a dictionary and getting back either nil or a valid playlist. So far, so good? Great. We had a question, hey, can we create an initializer without a parameter? Yes, we can. Here we have a convenience in it. It doesn't take in any arguments, right? No arguments. What do? We created some array here of names. Get me a random name for my array. That's going to be the name of the playlist. We use nil coalescing for that. Our track count, we defaulted it to 200. Our description, awesome coding music. All music is coding music. Is top 100, it's false here. So this is our convenience in it without any parameters. We went on to create a convenience initializer that only takes in a string, a name, only the name. But the name needs to be greater than 2 characters. Count needs to be greater than 2. Everybody with me? You pass in some playlists with 3, that's fine, right? 4, 5, 6. But anything anything less than 3, it's not going to work. It's not going to work because it returns nil here. It could return nil because this is also a failable initializer. Very similar to int string. Int string could return nil. Because if I say int letter 8, or rather character 8, it's not going to work. Right? So here, again, we're still calling our designated initializer. Still have to call it. So those are the 4 initializers we had, and this is our dictionary object, right? Where the key is the first part of that dictionary here. So we had a key, name, track count, description, and is top 100, right? We're able to test out our code. We created random playlists from our empty initializer here, the one that doesn't take in any arguments. We used the one that took in the dictionary, right? It returned us an optional. We had to unwrap it using optional binding. So that's initializers there in a nutshell, right? Those are the types you'll come across, and those are how you'll be using them. Any questions? Cool. So there's labs. There's a lab on like creating playlists or whatever movies it is. So go through that exercise. Make sure you're comfortable with that there. Any other questions?